Good afternoon. It's a pleasure for me to be with you this afternoon. I'm really pleased that Aviesan took the opportunity to set up this symposium on climate change and health. The topic of my talk will be the relation between air pollutants, meteorological conditions, and pregnancy outcomes. We all know that Greece is quite present in the media currently. I would like to mention Greece not for the present, but because of a very famous Greek doctor who made great contributions to biomedical research, Hippocrates. He wrote in his treatise on air, water, and places that whoever wishes to investigate medicine properly should consider the seasons of the year, the winds, the hot and the cold. So it was clearly referring to meteorological conditions. I think this was in relation to infectious diseases, but actually this is also very relevant for other health outcomes than infectious diseases. Many things happened since the 2,300 years and more that elapsed since Hippocrates wrote this. Very importantly, the industrial revolutions took place from about 1800. This was basically a revolution of the energy with the switch from mostly muscular and wind energy as resources to reliance on fossil fuel energies. In terms of environmental impact, the industrial revolution led to very strong increases in the levels of atmospheric pollutants quite quickly, and also led to climate change, as we know, with a bit more of inertia, but the effect on temperature is now present. Atmospheric pollution and climate change, as has been just mentioned, are interrelated. We know that the level of air pollution at a given time is, of course, related to the amount of pollutants emitted in the atmosphere, but that also there is a strong impact of meteorological conditions. Rain will bring particulate matter down to the ground, for example, entailing a decrease in the concentrations. Wind will also increase the dispersion, and if, on the contrary, you are in a situation with little wind, low mixing height, like we have on this picture from Grenoble, the place where I come from. Grenoble is below the layer of clouds and pollution that you see. This is the best situation to create a peak of particulate matter like we typically have in Grenoble and many other areas in nice winter days. The relation is more complex than that. For example, black carbon particulate matter are contributors to greenhouse effect since they store heat. They have, however, a much shorter half-life in the atmosphere than greenhouse gases such as carbon dioxide. What about health? Both atmospheric pollutants and climate change and meteorological conditions can impact health. I don't want to repeat the overview that has just been given by Robert Barouki. We know that atmospheric pollutants have strong impacts on the respiratory system, on the cardiovascular system. This entails a huge burden of disease with a decrease in life expectancy by 6 to 9 months in urban areas like Paris. Atmospheric pollutants may also have impacts on the central nervous system, on reproductive function. Climate change has also many impacts, including on the cardiovascular system when it comes to extreme events such as heat waves. Casualties from natural catastrophes are induced. Infectious disease prevalence can also be modified by the climate change. And there might also be an effect of climate change-related events on reproductive function. So there are at least two systems of related to our health that may be both influenced by atmospheric pollutants and climate change, a cardiovascular system and reproductive function. There may be others. I did not mention the immunological system here, but there are probable links with these two environmental conditions, of course. What I will do now is present some recent results on the relation between atmospheric pollutants, meteorological factors, and pregnancy outcomes, in particular low birth weight occurrence and preterm delivery. This is a rather recent work for our team, which we have done in the context of ESCAPE European project. This was a broad project on the health effects of atmospheric pollutants, considering not only birth outcomes, but also lung cancer mortality. And my team was in charge of the birth outcome work package. In this context, we have pooled data from 14 existing cohorts from 12 European countries, amounting to a total of 74,000 mother-child pairs. We have chosen to conduct not a meta-analysis, but really a central analysis on individual data, which allowed us to have a good quality control, and the fact that we could rely on existing cohorts allowed us to control for a large number of potential confounders, including body mass index, maternal smoking, socioeconomic status. We focused on preterm delivery, so a birth before the end of the 37th gestational week, and low birth weight among term births, meaning a birth weight below 2.5 kilos among term births, and control for gestational duration. The project allowed to have standardized measurements of atmospheric pollutant levels, including nitrogen dioxide and particulate matter, according to measurements done in each of the study areas, and a further step of land use regression modeling. This is an example from one of the participating area, a fine-scale outdoor air pollution level. And in the analysis I will present, we have controlled the air pollution effects for weather conditions, but did not adjust the effects of meteorological factors for atmospheric pollutants. So starting with the association between atmospheric pollutants and occurrence of low birth weight, we have observed a monotonous relation between the concentration of fine particulate matter, PM 2.5, that was below 2.5 microns, during the pregnancy, and the occurrence of low birth weight. This was a monotonous relation with a slope corresponding to an odds ratio of 1.12 for each increase by 5 micrograms per cubic meter in PM 2.5 levels, after adjustment for the factors I have mentioned and meteorological conditions. This was done in European areas in the last years, and these areas were most generally respecting the current European regulation in terms of fine particulate matter, which is currently a yearly average of 25 micrograms per cubic meter. So this is way above the WHO guidelines for particulate matter, which is around 10 micrograms per cubic meter, but below this EU limit, regulatory limit. You see that this is a weak level at the individual, a weak effect at the individual level, but given that in these urban areas the frequency of exposure to these atmospheric pollutants is very prevalent, the corresponding public health impact at the population level is very large and makes fine particulate matter and the related atmospheric pollutants one of the main controllable risk factors of low birth weight. There are several mechanisms that could explain such an association between particulate matter levels during pregnancy and birth weight. It is not always easy in such large-scale epidemiological studies to go inside the body and look for such mechanisms, which is the reason why we have, with our colleagues from INRA, Jouy-en-Josas, and the group of Pascal Chavat-Palmer, conducted an experiment in which we have exposed pregnant rabbits to the exhaust of a diesel engine. It was a diluted diesel engine exhaust throughout the pregnancy, with, of course, a control group exposed in, raised, bred in similar conditions, using an exposure chamber that was developed by our colleagues from RRM in the Netherlands, with a concentration of particulate matter during pregnancy corresponding to an average of about 60 micrograms per cubic meter. So this is higher than what we have here, maybe 2 or 3 times, but not that far from what is on the Paris Ring Road, and much lower than what you would have in some Chinese cities such as Shanghai. And the first preliminary result of Pascal Chavat-Palmer's group tend to indicate that exposure to diazole exhaust had an effect on the placental development. This picture shows in black the surface of the fetal capillaries in the labyrinthine area of the placenta, and you see that, it was estimated that the area of these fetal capillaries was much lower in the exposed versus the control group, which indicates that maybe one of the pathways of actions of this diazole exhaust is through alterations of placental function and decrease in the maternal placental-fetal exchanges. If we now move to the occurrence of low birth weight in our human population and the influence of the meteorological conditions, we observed an increase in the risk of low birth weight occurrence with increasing humidity levels and an increase in low birth weight occurrence at low atmospheric pressure. This effect is very coherent with what we have known for decades, namely that in altitude societies, the rate of low birth weight is higher, and altitude will cause atmospheric pressure and oxygen pressure also to decrease. There was no evidence of an association between temperature and low birth weight risk in this population. If we now go to the preterm delivery outcome, there was no association with the atmospheric pollutants that we considered in whatever time window, be it each trimester of pregnancy or the last weeks before the end of the pregnancy. There was, however, a strong association with all meteorological conditions considered, starting with temperature. You see here that the risk of preterm delivery increased by about 13% for each temperature degree lost towards the cold temperatures, and that the risk of preterm delivery increased by about 6% for each additional degree towards the warmer temperatures. And again, this is European populations from Norway to Spain and Greece. There were also associations with humidity and pressure, such as depicted here. As you see, for temperature, we observe a U-shaped association with the risk of preterm delivery, which is actually similar to what has been highlighted in the past in relation to mortality. And this is a result from the group of Patkine in Manhattan relating temperature to mortality. So it seems that extremes of temperature are not only deleterious for mortality in adulthood, but also for the occurrence of preterm delivery. We will try to better understand these associations and confirm them. This is new research for our group, as I have mentioned. Actually, for us in the beginning, these atmospheric conditions were simply adjustment factors in the association between air pollutants and birth outcomes, which were our initial interest. And by considering these meteorological conditions as adjustment factors, we have come to realize their strong impact on these birth outcomes. In the future, we will further consider these issues, trying to improve the quality of assessment of exposure to air pollutants and also meteorological factors, relying on personal monitors to particulate matter and gases such as nitrogen dioxide or benzene. We will look at specific mechanisms, including gene methylation and expression, and also maternal cardiovascular function during pregnancy. This will be done in CEPAGE, a couple-child cohort that we conduct currently at Inserm Grenoble, and also helix exposome projects with our colleagues from CREAL Barcelona, as well as toxicological experiments. So this project, I think, is one of the first analyses of birth outcomes that jointly considers atmospheric pollutants and meteorological factors. We did not highlight an effect of atmospheric pollutants on birth outcomes, on preterm delivery risk. Several other studies in other areas have highlighted such an effect, and I think our study does not preclude, of course, an effect of atmospheric pollutants on preterm delivery, in particular on preterm delivery with specific etiologies, such as preterm delivery in the context of preeclampsia or gestational hypertension. But we could not focus on hypertension-related preterm delivery in this large population. The information was unfortunately not available. There's increasing evidence regarding an effect of meteorological conditions on birth outcomes, and at least in the case of preterm delivery, we could show that this was not mediated by atmospheric pollutants. And given the highlighted relation between temperature extremes and preterm delivery, I think that we should start considering adverse birth outcomes as potential consequences of the climate change. I would like to warmly thank my collaborators from Grenoble, from Inserm Creal, Joint European Associate Laboratory, and all ESCAPE participating centers. Thank you very much.